Welcome to lesson number 7 of Unit 2. This is on graphing polynomial functions. This lesson has been a nightmare for me in the past. Hopefully, I will make this as clear and easy for you to understand as I can. First of all, we need to have a polynomial function written in standard form. Standard form means that we have the highest power first, and then we write them all in descending powers, right? So I have x to the n, and then I would have one less, and then one less than that. Okay, so that would be in standard form. What we need to look at for graphing polynomials are two things. We're going to look at the degree, which we had already talked about. That'd be the power on your variable. Okay, so that's the degree. And the lead coefficient. The lead coefficient, right? Whatever number that happens to be here. What we're concerned with is the sign. Okay? And that's going to depict end behavior of our function. What do we mean by end behavior? Well, if we're looking at a coordinate plane, it's going to be starting from somewhere, usually the infinities somewhere, right? And it's going to be moving somewhere, and then it will end either in the positives or negatives somewhere. Okay, so we want to figure out where does it start and where does it end. And we're going to figure that all out just by looking at the degree and lead coefficient. So I have here this nice little table of end behaviors. So if you want to take a second to pause this video and copy this chart, and when you're ready to start filling things in, you can resume it. So let's start filling out some of those blanks right now. Okay, our first one is if we have an even degree, right? Our power up here is something like 2, 4, 6, 8, 10, okay? And our lead coefficient is positive, right? We have a positive number in front. That's going to give us this general shape. Okay? What's happening with our end behavior is we're starting positive and we're ending positive. What happens in here, it could be anything. We could have squiggles if we wanted to. There might be a gap in the function. But what's important is these end behaviors, start and end positive. If our degree is odd, right, we have something like to the power of 3, 5, 7, 9, right, an odd degree, but still a positive lead coefficient. We get this general shape. Our end behavior, we start off negative, but we end positive. Okay, well, we'll keep that right where it is, sorry. Here we have an even degree again. So even, we notice that they were both in the same direction. Positive, it was pointing up. So what's going to happen when we have an even degree with a negative lead coefficient, it's going to flip everything upside down. So if we have a negative number here and then a 2, 4, 6, 8, whatever, our end behavior looks like this. We start negative and then we end negative. Last, if our degree is odd, right, we're going to have this right opposite kind of look to it, but we want our lead coefficient to be negative. So this whole graph is going to flip. That means we start up here at the positives, and then we're going to end at the negatives. Start positive, end negative. Now, before I go any further, I would suggest that you keep this somewhere that you can use as a reference until you have this ingrained in your memory. Okay? Until that point that you have it memorized, you need to know how the end behavior works. Okay? This one I think is the easiest to remember because you've been working with parabolas forever. And we know if we multiply it by negative, it's going to flip upside down. So these two are a little bit easier to remember. These ones, people get confused because they're already facing two different directions, but then all of a sudden they flip. So you really need to get these down pat before you start working on the problems themselves. Okay, there's two more things that we got to look at before we can start graphs. We want to look at the zeros or roots. They're the same thing. They're also known as solutions. But here's what's going to happen. If we have an even power, we're going to have an even number of real roots. If we have an odd power, we're going to have an odd number of real roots. This is generally speaking. There are times you might have, say, an even power and an odd number of roots, but that's a little bit more of a different discussion. For all intents and purposes here, we're going to try to remember this. Okay, that's what we want to try to remember. As far as turning points, this is always true. Turning point is where the function suddenly changes direction. Whatever our degree is, it's going to have one less turning point. This is always true. So if we have a degree, say, of 7, right, x to the 7th, that means that there's going to be 6 turning points in our graph, and we will go over what that looks like in a moment. So this graph, we need to know it. These, just a good thing to kind of keep in mind, even though it's not necessarily always true. It's something to keep in mind. It's a rule of thumb here. And then the turning points, this always works. We always have one less. In fact, when we look at a graph, we're going to be looking at the turning points to try to determine the actual power. Okay, so this always works here. Let's see what these problems are going to look like in practice. Here you go. Okay, so they'll be giving you problems that look like this, right? They have a graph. They want us to determine what the lead coefficient is in terms of positive and negative. They want to know what the degree is, right? The actual degree. And then the number of real zeros. So we've already talked about real zeros. They're just solutions. They're roots. They're where the graph hits the x-axis, where it intersects. So there's a couple of things that we've got to look at. If we want to know the lead coefficient sign, we're going to look at the end behavior. Okay, it's telling us right now that we're starting positive and we're ending negative. Looking at my chart, I know anytime that we end negative, it's always with a negative lead coefficient. Okay, so that's our lead coefficient. We want to know the actual degree. Well, we had said that there are turning points. Let's look into our function right here, right? I notice right here, my function is coming down. All of a sudden, it goes back up. That's a turning point, right? The function has turned at that spot. So basically, anywhere that I notice that it's going the other way, I'm just going to put a little mark. Okay, so I've made little marks at each of my turning points. I'm going to count them. I have 1, 2, 3, 4 turning points. Now we had said a moment ago that the degree is one more than turning points. So if there's 4 turning points, that means I have a degree of 5. So we'll write that as x to the 5th, right? That's our degree that we have here. Last thing they ask for is the number of real zeros. Well, it's just how many times it hits the x-axis. I see it hit once here, a second time here, and a third time here. So we have 3 real zeros or roots, however you would want to call them. By the way, one last thing just to check, right? We had x to the 5th, which is odd, and notice how our end behavior is acting the way an odd function would, right? One going one way, one the other. We have a second example. Okay, again, I'm looking at end behavior. Here I'm starting off negative and ending positive. I ended positive. I know that my lead coefficient should be positive. I'm going to now start checking out my turning points. I have 1, 2, 3, 4, 5. Looks like 6 turning points, so I need one more for my degree. That would be x to the 7th. And then how many times does it cross the axis? Crosses 1, 2, 3, 4, 5 times, so that's 5 real zeros. Once you get the hang of these, they're actually kind of fun. right? I'm going to look at my last one, looking at my end behavior. It starts positive, it ends positive, the whole thing is positive. Now I'm going to look at my turning points. I have 1, 2, 3, 4, 5 turning points. So I want one more for my degree, so that's to the power of 6. And then we'll see how many times it crosses. Once, twice, 3, 4, 5. Crosses 6 times, so we'll say 6 real zeros. You have 3 to try out on your own. Use the little table that we had before if you need to, and keep in mind that you have 1 less turning points than degrees. So try these ones out and resume the video when you're ready to check your solution. Okay, let's see how you did. Starting off by identifying end behavior. That tells us negative end behavior. Next, we check our turning points. 1, 2, 3, 4, 5 turning points would be 1 less than the degree, so we have a degree of 6. Then we want to know how many real zeros. Looks like this crosses 4 times, so that would be 4 real zeros. Your second problem, you start positive, you end negative. That gives us a negative lead coefficient. I'm going to check my turning points. 1, 2, 3, 4, 5, 6. So we want x to the power of 7. Right? It's 1 less than turning points. And how many times does this cross? Well, it doesn't cross at all here. It crosses once, twice, 3 times towards the end. So it has 3 real zeros. And our final, we start positive, we end positive. The whole thing is going to be positive. Turning points, we have 1, 2, 3, 4, 5. So that means we have x to the 6th power. And how many times does it cross? It crosses once, twice. So 2 real zeros. I'm hoping that you did well with those. Graphing polynomials is pretty easy. We're going to now go in reverse. Right here they gave us a function we had to identify. And what your task will be now is it will give you specifications and you will need to graph. Here's the deal with these graphs though. Your solution will probably look different from my solution in all sorts of different ways, right? Maybe you have everything crunched in and my stuff is spaced apart. Maybe your turning points are nice and tall where mine might be short. So there's infinite numbers of solutions. What I'm going to be looking for are your end behavior, the number of turning points, and the number of real zeros. That's what I'll be looking for. Okay, so if your solution looks different, don't worry about it. How we're going to tackle these? Well, they give us some information, right? We have a function that's negative, and we have a degree of 6. So those two things are very important because I have an even and I have a negative. I know my end behavior, and I'm going to draw this in first. I'm going to start negative and end negative, right? Because that's what's associated with negative evens. So I drew those in right away. Okay, then I can start talking about my real zeros. This is how many times it's going to cross the x-axis. So what I'm going to do is I'm just going to put 4 points along this axis. Right, here's 1, 2, 3, and 4. So now I've got my real zeros taken care of. What I want to do is make sure that my function that I draw has enough turning points. And I want to have 1 less than the degree. So the number of turning points I should have would be 5. But I need to cross each of these at least once. So I got to do this carefully. Okay, I'm coming in through here. I haven't turned yet. That's going to be my first turning point. Right here is 1. I'm going to come through here. Okay. Now I'm going to go back up through. So that's my next turning point. I have 2 so far. I need 5 of them, and I've only got 2. And if I go straight through, that's only going to give me 3. So I'm going to have to do a couple of turns up here. All right, that gave me 3 and 4, but now I have to turn back one more time to go through. So that's my 5th one, and then right out. Now, these have to be there. They can't be up here. You can't have them switched. So I would be checking to see that those are where they are. These, where they cross, maybe they're all crossing only at the negatives. I don't know. Those could change, but they should only cross 4 times. And as far as my little bumps, my turning points, I know I have to have one less than the degree, so there should be 5. So I would be checking to see that you have 5 of those. So if your solution doesn't match exactly, don't worry about it. Okay, we're just sketching what we think it might look like. So I'm going to do one more with you, and then I'll give you 2 to practice on your own. Okay, same type of instructions. This time we want a positive lead coefficient with degree 5, so it's odd. That means that we start negative and we end positive. Okay, so I've already taken care of my end behavior thanks to this. I'm going to have 4 turning points, right? One less. So 4 turning points, and it's only going to cross once. So I'm going to put in my point right now. I'm going to make it cross right here. That's my one time. But it needs to have 4 turning points. So that means that in between here and here, I'm going to have it turn a couple times. So let's see. Maybe I'll have it turn once, twice, 3 times, and that'll be my 4th right there. So I've got my 4 turns covered, and now it's going through only once. That looks pretty good. Matches everything that we needed. So you've got 2 to try on your own. Again, I want you to pause the video and resume when you're ready to check. But again, will your solutions look the same? Absolutely not. Most likely it's going to look completely different. But you're just checking to see that you have the correct end behaviors, roots, and turning points. All right, let's check this out. Let's see how you did. So we have positive and a degree of 8. So that's positive and even. That means that we start positive and we end positive. We have 4 real zeros, so I'm just going to throw in 4 points where it's going to cross right away. If we have a degree of 8, that means we have 7 turning points. I'm going to take care of some turning points right away. Let's take care of 2 of them. Here's 1, 2. This is going to give me a 3rd. This will give me my 4th. This will give me, let's see, so I only got 4. I'm going to need a couple more. So 5, 6, 7. So I've taken care of all the turning points I need. I've now crossed. I'm just going to come right out to my end point. Okay. And for the next one underneath, here I have a negative and a degree of 7. So if it's negative, that means we want to start positive and end negative. We're crossing 5 times, so here we go. I have 1, 2, 3, 4, 5 times, and we should have 6 turning points. So let's see. Here's 1, 2, 3. We're going to need a couple more. So let's see, 4, 5, 6. And then we'll go right out to my end behavior. All right. Ugly looking arrow. Right, but so that's what we're checking for, right? We want to make sure that we have the correct end behavior. How many times does it cross? How many times did we change direction? If your graphs have the same qualities as mine, then they're correct. Hope that you did okay with these graphing polynomials. I think they're kind of fun to do once you get the hang of them. If you have any questions, bring them into class or leave them on the comments, and I'd be glad to answer them as soon as I can for you. See you soon.